So I'm Kristin Morris. Today we're conducting an interview with Boris Weissman. This interview will be part of the VMware Founders Collection at the Computer History Museum. Boris, thank you so much for taking the time to talk with us today.
Thank you for having me.
You're very welcome. First, I'd love to start with a little bit about you and your background that brought you to VMware.
Sure. So I've overlapped a little bit with some of the founding engineers and founders of VMware before. So I remember when I was doing my PhD at UC Berkeley, I remember coming back to a research talk by Mendel Rosenblum, who was at the time professor at Stanford. So we didn't overlap at Berkeley. I was a generation behind. But he came back with his students to talk about SimOS, which was a research project at Stanford and a precursor to VMware. And he took his students and started the company a couple of years later. And of course, I knew some of the original engineers who came also from Berkeley days. So that's sort of the short history. Of course, the longer history goes all the way back, across the continents, and I don't know how much of that you want to hear.
I always like to hear from people what sparked your interest in computing technologies.
Right. Okay, so let's start on the beginning then. So I was born in rural Ukraine in 1960s, late 60s. This is where I went to school, high school, started college. This is where I was first introduced to computers, and I think it was a System 360 at the time, and we used punch cards and Fortran and things like that, and that was actually licensed. There was a PDP-11 clone. I'm not sure if that was ever properly licensed or not, that we also used, and then later on we got PCs, and that's sort of where it all started. And then at the end of the Cold War in '89, I came to the U.S. to finish college and then go to graduate school at Berkeley, and since then it was computers most of 20 hours a day.
What was your research work in for your PhD?
Yeah, so my thesis was on programming languages and distributed programming languages. The larger group at the time that was using the language that we developed was actually AI group, a neural network group, and a lot of what you hear these days about AI, neural nets, all of that was, the research was, been done in a broader group. But personally, I was always focused on building systems, and so it was, programming language was Caesar. It was before Java, but it had a lot of elements of Java. And for a few years, I was maintaining a compiler and the language. And then, of course, when Java was started by Sun Microsystems, not far from here, by the time I finished, so Java was picking up, so I moved over to Sun to work on Java.
Mm-hmm. And how long were you at Sun?
Not very long. So that was during the dot-com days, so I was there slightly over a year. Luckily, I managed to work on the first version of the Hotspot JVM. And this is, to this day, 20 plus years later, this is what powers most production applications. So I was very lucky with millions and millions of users. So I worked on the Spark version of the Hotspot JVM. And we shipped the first release when I was there after a few years. So that was actually a great experience.
Mm-hmm. And how did you come to work at VMware?
So that's a great question. So I was at Sun, and at some point I wanted to actually get a job with a startup. Sun was doing really well at the time, but the writing was a little bit on the wall because, given by it just grew big and had a lot of innovations, but on the technology side, but they couldn't monetize it in any way. And I guess I've just read the book by Andy Grove, Only Paranoid Survives, and it was right, obviously he was writing about a period of Intel 20 years before that, but, you could have as well written about Sun Micro at the time. Anyway, so I wanted to try a startup. It was Silicon Valley, kind of made sense. So I did another startup before VMware called Loud Cloud, and that was Ben Horowitz and Mark Andreessen's startup. And then this is how we got into roughly the same area, very different approach, because in Loud Cloud we were trying to solve even the name such as the cloud problem, but not so much with technology. A lot of it was by hiring very smart people and basically applying processes and operations. And it was great during dot-com days when there was a lot of money to go around. But by 2001, it was sort of clear that the business model was probably not sustainable. So you need to apply a little bit more technology, a little bit more brain to solve it. And so I remember the first time I saw VMware in action. An office mate of mine was running Windows and Linux in his office. It must have been 2000 or 2001, early 2001, and I'm like, okay, that's very interesting. So how do you do that? And he said, oh yeah, so I'm running this thing called VMware, and I, been a PhD in computer science. I sort of understood how these things were done, right? You read all these papers about IBM 360, etc. But that was basically something didn't compute because IBM was built for that, right? The entire system was constructed for this. And they just virtualized the CPU. They never even attempted to go after the entire computer, basically virtualizing the whole stack, including, keyboard and a video card. And later, many years later, I was actually at IBM on behalf of VMware talking to the original engineers who were equally surprised that, the small startup with a bunch of students out of Silicon Valley, attempted to do these things that even they never thought, that were possible. So I was very curious, and then I guess I applied. And one of the founders, called me back, Ed Bunyan. And so I came to talk, and I had an idea of how that could have been done. I just didn't think they've actually done it that way because it was just so laboriously and so detailed. And basically, I couldn't believe that, a small group of engineers could have done something like that, right? Turns out that's exactly what they've done, and, they did. So the difficulty was x86 architecture, right? So they had experience doing the same for MIPS. Was much easier, much simpler processor. So they could do it within the context of the Stanford research group. But to do x86, they actually had to basically drop out of school. And even Mendel took a sabbatical. Mendel Rosenblum was a co-founder for a couple of years to do that kind of thing, and hire also others. And it turns out some of the people I knew from Berkeley, some of the people I knew from Sun, there were some fellow refugees from the JVM days because the technology was very similar. I mean, it's kind of, binary translation was the name of the technology until Intel actually did the proper thing, and AMD and implemented virtualization on the chip. But that was, almost 10 years, almost a decade later. But at that time, it was still, binary translation, which basically the amusing part is that, given a dozen very bright engineers and time, you could do anything in computing, and that was sort of another confirmation. That was sort of the heart of VMware. At the time, everybody worked on it. Mendel Rosenblum worked on it. Ed Bunyan. Basically, most of the founders still worked on that. It was the core of the group was a research group and Mendel students, and then that got expanded.
Mm-hmm. So what was your role when you were brought on to VMware?
So, well, the initial role was not to break anything, which is, amusingly enough, everybody failed that test. And I'll get to the broader role, but the first week, so I remember they gave me a bug that seemed like a simple bug, and I fixed something, I committed it, and I was very happy nothing broke. And then a couple of weeks later, Mendel comes to my office laughing, saying that they were all shocked that nothing broke because apparently there was a club of the first fix, breaking stuff, and it included everybody. So that nobody escaped it. So they were shocked for a while. And guess what? 2 weeks later, a CPU locked up, and they traced it to my first commit. So I didn't escape the black hole. And he basically said, you're in good company because everybody's in that club. But the broader, sort of the first couple of years, the big project was, so that was 2001, and they wanted to move. The initial product was what's called Workstation, and that was basically to try out, because the hypervisor or the monitor group, the monitor that was called in VMware hypervisor, that's what it's known by today. Because at the time it was such a tremendous fit of engineering, they kind of wanted a lot of people to try it to make sure it's solid. And the Workstation was a product which was a desktop product, right? It wasn't necessarily a money-generating product, but this is what I saw for the first time, maybe a year before. And that's what let developers run Windows on top of Linux and vice versa. But that was a single CPU product, so they could only virtualize one single CPU. To go into the server market, and Mendel's idea, even at that time, was basically cloud computing, to go virtualize server systems and run them at scale. And one of the technical problems was to go from one CPU to multi-processors, right? Even at the time, servers were running multiple CPUs. And that was a technical challenge at the time. So when I joined, there was a prototype that sort of tried to do that. The only problem was the more CPUs you added to it, the slower it got, which is the opposite of what you expect, right? So the reason you want to handle multiple CPUs to make your programs run faster, not slower. But because of the technical challenges, it had exactly the opposite effect. And because basically it was tail wagging the dog. There is a couple of parts of x86 architecture that had to be virtualized, and I don't know if I should go this deep technically,
Sure.
but so there were a couple of components on the chip called local APIC, advanced programmable interrupt controller, and a remote and sort of system-wide one. And basically virtualizing these two chips, that it was taking 70-80% of all the cycles in the system. So whatever advantages you potentially had in your multiple processors, they were totally negated by having to sort of virtualize all these extraneous things. And so that took a couple of years, but that was my original project. So that was around the ESX1 time frame, and going multi-processor, that basically put VMware on the line. And basically, I was sort of the main engineer on that, but the goal was to take the overhead from 70-80% to 1-2%, and a little bit at a time we got it there. That was the first big project. It probably took about 2 years to do. So the next project was equally interesting. Also took a couple of years. So VMware at the time, so that was interesting time. So I'm still talking about the period of time about 20 years ago. And the interesting part was that the chips were 32-bit. So x86 was 32-bit, Intel was making 32-bit CPUs. At the time, Intel and HP and Hewlett-Packard, they got together and they decided to make bigger CPUs, 64-bit CPUs, but to completely change the instruction set and to come up with Itanium architecture. And it wasn't just the number of bits, of course the number of bits in your address line and in your basically both instruction and data address lines. It has to do with how big your memories could get, how big of programming tasks you could handle. And at the time, so these two giants got together and decided to completely start from scratch and build a brand new CPU that would be 64-bit, but they also changed many other things. It could execute a lot more instructions in parallel. It had very complex instruction set. It also had very complex compiler with hundreds of people. I had some friends working on the compiler for many years. And sort of another lesson where, a dozen good people could do anything and thousands of good people perhaps not, because it took many years and it eventually failed. And of course, VMware at the time was a small startup, so product managers were encouraging us to, titanium, and they were all paranoid that, we were focusing on this x86, but it's like a toy. And in the meantime, Intel and HP were building this ginormous new architecture, and we were encouraged to go and try to virtualize it. That thing wasn't virtualizable either. But at the same time, AMD came up with a quite modest extension of x86 to 64-bit. AMD 64 it was called. And AMD, unlike today, it was a very niche player that was just kept around by Intel just for the second source for other software companies. But it came up with a very small team. It came up with 64-bit extension. And while we were sort of pushed back by the business people to focus on this big thing, it was very clear to us that it was just going to take many, many years, and adoption wasn't obvious. It was very complex. And my second project was to start a 64-bit effort to bootstrap the 64-bit hypervisor. And I kind of have to relive the second time what the founders had to do initially, because it was basically doing very similar things what they had to do with 32 bits, doing it on the 64-bit processor. Also took a couple of years, and to give Intel credit, they realized that the big bet wasn't working out, and Intel was potentially running away with this much more modest 64-bit chip. They funded a group to essentially do what AMD did. And luckily for us, by that time, we had AMD kind of working. And when Intel came with their 64-bit chips, it was sort of somewhat more straightforward for us to just adopt it. But yeah, so those two projects took years and years of my life.
Can you describe the team that worked on those projects? How did you work together as a team?
Right. So it was basically a mixture of people with, quote unquote, grown-ups. And I was sort of more towards a grown-up, but maybe towards the end of my tenure there. But basically people with, with research background who have done commercial products like JVM before and knew what it takes, not just to do a research project, but to keep it running so you have millions of people use it. And then, the team was very strong. So, for example, Ole Agesen, one of the people I remember from my Sun days, so he was a Stanford PhD who joined Sun a couple of years ahead of me to work on the JVM. So I remember him leaving Sun, and I didn't know where he went, and he ended up at VMware. So I would say there were a few people like that, and then VMware in the initial days did extremely well attracting young talent from anywhere in the world. So we had a bunch of folks with interest in building kernel systems in their, just a year out of college. Because there was, at the time, even today, there aren't that many places you can do that sort of thing. So we had, folks from, 22 years old who did kernel work their entire life, coming out of all kinds of, Stanford, of course, was a local place. Berkeley, Brown University was very good. Remember hiring a very smart person who worked in a research project in Moscow, and was 222, was amazingly bright. So that was basically about half and half, I'd say. And Mendel was still there, so Mendel was still working on the hypervisor. As I mentioned, Ed Bunyan, the other founder who was Mendel's student, was a manager. My hiring manager was still there. There are a couple of others, Stanford PhDs, who came over. So that was a mixture.
Mm-hmm. Can you share what it was that attracted you to working with, you worked on, you wanted to be in a startup environment, you said, and I'm wondering what it was that attracted you to that particular kind of environment over a more established corporate, you mentioned a little bit, or even over academia?
Yeah, that's a loaded question. So even though I got my PhD at Berkeley, to my disgrace, I never wanted to pursue an academic job, which eventually turned off my Berkeley professor. So at the time, Berkeley is different now, but at the time, the main focus was, producing professors, unlike Stanford. There was little respect about Silicon Valley, or even industrial research was sort of for people who couldn't get a teaching job. But I had no such interests, so I always wanted to sort of go back into industry. Of course, the challenge is you want an interesting job. At the same time, you want it to be commercially successful, and that's sort of a unicorn, hard to find, right? So Googles and VMwares of the day don't come often. And as I mentioned, I did a startup before, so I knew what a startup life is. So at the end of the day, it's about survival and making it. Which sort of that goal runs counter with spending time and designing things and carefully and making sure things run for years and years. So VMware was unique because it offered both opportunities. So it was very much a startup. So when I joined, the whole company was, around 100 people. And that's including everybody, including sales, not just engineers. But at the same time, there was always this understanding that this type of technology, even at that time, we understood it would exist for 20 years. So you couldn't cut too many corners, right? And that combination was unique because in Silicon Valley, very, very easy to find a startup. It's also not difficult to find an interesting startup that would probably fail. Mm-hmm. Find a combination of the two, that was a challenge. So VMware, was there for sure for me. Yeah, I was actually very happy about that choice. Yeah.
So you were at VMware in your first stint for 10, 11 years. How did your career progress through that decade?
Right. Yeah, so I was fortunate enough to do 2 tours of duty at VMware. So that was sort of the original VMware. That was 11 years, from 2001 to 2012. VMware changed, so lots of growth happened. The company was acquired originally by EMC, then it went public in 2007. Then most founders left in 2008 during the financial crisis. It was, the new chapter started with EMC controlling the company, but at the same time, everybody understood that, the potential, so nobody wanted to VMware not to succeed. So new executives were brought in. That was sort of a difficult transition, 2008, when Microsoft executives were brought in, the CEO and a couple of people under him. And the reason it was difficult is Microsoft was sort of the competitor number one at the time. And at the time, it was really strong, especially in systems. It is strong now, but now it's diversified. But in those years, the focus was operating systems, and Microsoft very correctly considered VMware as a sort of competing head-on, in the system space. And much of the time we were competing with Microsoft. And suddenly we had a CEO who was number 2 at Microsoft, who was running both Windows and Office, who brought in a couple of people who worked for him at Microsoft. And there was a difficult transition. At the end, it kind of worked out because, at the end of the day, we had the same customers, and the companies were different but also similar. But anyways, by 2012, the company grew. It was too large. I was there for 11 years. The core technology kind of stabilized. And, I got another startup bug. I wanted to try something new. Also, I spent most of this time working on CPU virtualization. And basically, that problem, by and large, I'm not saying it was solved, but Intel added hardware support, so did AMD. So it sort of became more of a, difficult engineering problems and rocket science. Binary translator was removed. It was replaced by sort of more natural code. Anyway, so in 2012, Ganesh, who you also interviewed, and myself, so we decided to try something new and start a company on our own. So by that time, we kind of both were principal engineers at VMware and looking to, just start something new in the enterprise space. So we started a company called Datrium. That was 2012. And amusingly enough, in 2020, it was acquired back by VMware, and this is how I started my second tenure here.
So what area was Datrium involved in? What's the main product there?
Right. So the main product there was it was in the storage and data protection space. So the initial product was storage for virtual machines, because at the end of the day, this is what we knew. And so the observation was that the compute part, VMware changed the landscape completely. In 10 years, 90+% of enterprises were virtualized. All the workloads were virtualized, but nothing else has changed. Neither networking nor storage changed. And storage was a little bit closer to us, but the understanding was that both would need to change. And VMware, on the networking side, it acquired Nicira, that became the SDN solution in NSX. On the storage side, changes happened as well, but not at the time when we left. So the observation was, it's just having old arrays. The use case mutated, so the technology should mutate as well. So we started a company to cater to that. And the original product was a storage appliance. Over time, we added cloud features, and we started in the primary storage, but we added data protection capabilities. We always wanted to have self-protecting storage that would basically be able to handle millions of IO operations, but at the same time would be able to protect itself. And then we kept adding data protection capabilities, and eventually added cloud data protection, and that was the technology that VMware wanted to acquire. Not the original product, but everything else that followed. And in 2012, that was a little bit of an interesting acquisition both for us and VMware, because that was right after the pandemic started. So VMware shut down, and they wanted to buy us, but they didn't know how to do it without talking to anybody in person. That was their first remote acquisition. So the good news was they knew us, and this is probably why they wanted to do it with us, because at least they knew people. The bad news was, like, Zoom was new to everybody. Like, we've done everything over Zoom, including technical due diligence. And I remember that was an interesting experience in itself, because so the way this is done, because of the intellectual property issues, the acquiring company doesn't want to look at the source code of the company being acquired. And the way it's done, they hire these companies specializing in IP evaluation, and they hired exactly the same company to evaluate Datrium that EMC hired to evaluate VMware in 2007, which was interesting in itself, but for them it was also the first remote evaluation. Because normally the way it's done, they fly in and they spend a month with you in a room with no windows, and you kind of walk them through the architecture, through security, through everything, and it's kind of real time, like the conversation we are having, where they ask you a question, you give an answer, they ask you a question, you give an answer. But all of it was impossible, so all you had was Zoom. So we were kind of all learning during the process, but it definitely helped that it was not a random acquisition, that there was a fair amount of trust on both sides.
Did you feel like VMware was a natural fit for the product that you had developed there at Datrium?
Yeah, right. So that was one of the questions we wanted to answer for ourselves, because we thought there was value in the product. We wanted to keep the engineering team. We wanted to keep the product and the code base together. And so we were looking for a potential acquirer at the time who would basically satisfy these requirements. There were a couple. VMware was definitely at the top of the list because, as I said, there was enough trust established. And by that time, we were also working with VMware as a partner. So VMware released what's called VMware Cloud on AWS, and for a couple of years, we were one of the sort of initial users of that technology, and then we built data protection features for that using that technology. And yeah, so it was pretty clear that VMware was interested in basically building on top of what we had, which they did. So the product stayed, we released the product re-released the product. So within 100 days from being acquired, we re-released the product under VMware, which was an interesting experience because obviously VMware at the time was, 35,000 person company with all kinds of requirements that startup doesn't need to satisfy, and basically we had to integrate with all kinds of things VMware had. But yeah, VMware was good to us. The product is doing really well. And we were also fortunate enough to get their support to release a few other related products. So the original one was data protection to protect against, let's say, natural disasters like fires when your data is destroyed. But we noticed back at data room days that the use case was mutating, and more of our data room customers were using our platform to protect against cybercrime and ransomware than from natural disaster. There's lots of similarities. Your data is hijacked, it becomes unusable, so you need to use backups that are somewhere else. There were differences as well because your backups are not what's called clean. They may be infected, so you have to be very careful. When you're recovering from cybercrime, you cannot trust any data. But anyway, so we noticed that the use case started to mutate, and in our field, that usually means you need to build a new product when the use case changes. And about a year ago, we released a product, ransomware recovery product, VMware Ransomware Recovery, using a lot of the technology we developed at Datrium, the underlying file system, the orchestrator. But the main focus is ransomware and how you secure it. Basically, how do you help VMware customers to recover from ransomware in a predictable way, but obviously without having to pay ransom.
What do you see as the landscape for the security protection? Like, where is it going? What problems does it still need to solve?
Right. So by that time, so having spent the first 11 years at VMware on basically core virtualization, and then the next 8 years working on file systems and storage and data protection. So I sort of had the basic knowledge, but the security aspects were new to me. Because suddenly these products have to combine all these disciplines, right? All the normal sort of storage file system stuff, but security people don't speak the same language and vice versa. So a couple of years ago, I started reading up on that, right? Because I was, coming from sort of traditional background, the core, systems background, and starting to talk to security people. And VMware acquired another security company called Carbon Black, and there were a lot of senior people there who understood the security space. So we started the dialogue, and I remember the first couple of months. It was hard to understand each other because they didn't speak the same language we did, and they kind of looked at us as VMware people, even though we perhaps were VMware people, but we were also, startup people, and they were security people. But anyway, so once you find the right people, there was an agreement that there was very little help offered for recovery, because the security system was focused very much on prevention. And in the case of ransomware in particular, prevention is failing, because every time you hear about a ransomware attack, this is when prevention failed, right? And then as far as the security industry is concerned, it's somebody else's job to recover, because they just do prevention and response. And if things went too far and your data is encrypted, it's somebody else's job to recover. And similarly, if you look at data protection industries, these guys are more traditional backup. So they back things up, they can restore things. But if you're restoring potentially harmful content, they point to security people. And it's not just in VMware, it's everywhere, it's like that. And sort of breaking the barrier is a challenge, because we want to have a product that caters to kind of two cases at the same time, in intersection of these two cases. Who's your customer? It's your infrastructure person, it's also your security person. So where this is all going, I think the security problem is much more difficult than traditional data protection. Because traditional data protection is protecting you against natural disasters. And there, your adversary, yes, you can lose your data, but a number of techniques were developed over the years. You move your, if you know the hurricane is coming, this is an example from data room days. We had customers in the Caribbean. Every time they knew hurricane was coming, they would try to do additional backups to move their data off the island, and so this way, if something happens, they lose less data. And then you have your orchestration products to recover your data back. But it's predictable, because as long as you have your data backed up somewhere safe, and you have your tools, you can bring it back. Even if your data center is gone, you build another data center, you restore the latest copy. Problem with cyber recovery is your latest copy is bad. It could be encrypted. It most definitely infected. And you can go back a day or a week or a month, and your data may not be encrypted, but it probably is infected. So there is this concept of dwell time in security, and there is no such thing in other fields, in data protection, only in security. And dwell time is the amount of time between infection and, in the case of ransomware, encryption. And the reason it's not instantaneous is that when the attacker gets into your system, they need to find the most valuable targets. Until they do that, the goal is to hide. And your most valuable targets usually are financial databases. It's something that is critical to your core business, depending on your domain. Could be different database or a different system, but it's something that you will pay money for. And this is sort of core target number one, and core target number two is the backups of these core systems, because that's how you recover normally from backups. Once they discover your mission critical systems and the backups of your mission critical backups, this is when they go full speed and encrypt everything. Now that duration of time where they collect inventory, and these days especially for these attacks on big organizations, it's usually humans who do that. So it's not just software. Yes, they use software to get in, but then they inventory your systems, and they have very smart people. Your adversary is very, very smart, who go over your system and try to identify what's important, what's not important. Oftentimes they know your computing system better than you do, and it takes time, sometimes months. And during that time, you have somebody lurking, and looking around. And this is what makes us difficult, because if you recover, potentially, let's say everything was encrypted, you can go back in time, let's say a day. And by the way, encryption usually happens during holidays, along weekends, because they want to have the maximum amount of time to encrypt everything at high speed. But anyway, so if you're not very careful and you go and recover, but you haven't validated your backups, you could be re-encrypted the next day, because whatever vulnerability was used initially, it may still be present there. If the adversary had access to your system before, they probably still would have it. So the trick is to clean the backups, right? To plug in all the holes, and in addition to recovering your data, also make sure that after recovery it's no longer compromised. And I going back to your question. Because your adversary is human, I think that problem is going to take a while to solve. It's not as easy as dealing with natural disasters, because it's evolving. So as we build better tools for protection, they build better tools for attacking. As we use artificial intelligence for anomaly detection and other things, they use it to break into your systems, and this is sort of escalations that will carry on, and this is how security was for the past 20-30 years, and and it will continue that way.
Is there a product that you worked on at VMware that you point to as sort of a career highlight or important moment?
Yeah, I would say there were two. So the first one was a hypervisor for multiprocessors, and there I was a part of a team, and this is what put ESX as a VMware flagship hypervisor. So that was, it just made it basically acquire enterprise customers. So that was a SMP, what we called SMP hypervisor monitor, and the second one was 64-bit. Both of these are still in use today, 22 years later. So the underlying code, I'm sure many of my bugs were fixed, but it's still running, right? And this is not something that you can point to back 22 years and say, hey, there's a piece of my code that millions of users still use 20 years later.
You mentioned a few of the founders earlier. Are there other people that you've worked with that you would say had a lasting impact on your career and your work?
Yeah, so obviously starting with the founders, I worked with most of them before we get to other engineers. Most founders were engineers. So at VMware was very special in this way. In fact, other than Diane, and Diane was an engineer by training, but she was a CEO. The other four founders wrote code for many years. And I worked with all of them. And some longer than with others, but of course, Mendel Rosenblum was a visionary, and by the way, not just virtualization. Obviously, that was his baby for x86, and you can make an argument that all cloud computing, AWS, Amazon, Google Cloud, Azure, all of it traces back to Mendel's research group at Stanford, SimOS. But interestingly enough, I have another project to thank Mendel for. So his PhD thesis at Berkeley was on something called log structured file systems, LFS. And I don't want to go into the details of that, but so that was, we are talking about early 1990s, 91, 92. When SSD, solid state storage, came along 20 years later, 25 years later, flash storage, amusingly enough, all of these file systems that run either inside SSD disks or even data room file system, they were all based on the ideas from Mendel Rosenblum's thesis that goes way back when none of these devices even existed. And the reason being, Flash is very good at sequential accesses, but writing randomly that's not something you want to do on it. But anyways, so there was a sort of a seminal paper that Mendel wrote back, I think it was 1992, on log structured file system, and that was his PhD thesis. And I was fortunate enough to be with one of these IEEE conferences a few years back, when Mendel was awarded, I think 25 years later, for this paper. He got a 25-year award because it sort of was foundational. It has nothing to do with virtualization, but this entire storage field also traces back to this project. So that was, the project was Sprite research project at Stanford, and LFS was Mendel's thesis. So obviously Mendel and Diane, of course, without her, there would be no VMware. And other Ed Bunion was a hiring manager, became VMware CTO. He eventually came back to finish, you guys probably know, to finish his PhD at Stanford 14 years later. That was amusing, on the binary translator that we used in the V1 version of the product. Helen Wong, amazing engineer. Scott Devine, same thing. So all the founders. And then others, so Ole Agesen is one of a kind. So he was the first VMware fellow. He kind of took over the hypervisor from Ed Bunion and Mendel. And if you want to have something running and last 1 year, you give it to Ole, he'll make it happen. Pratap, who's another fellow, still with VMware today, so he was in the same group. Of course, I met Ganesh there, and 22 years later, we still work together. Yeah, so there was a lot of people I'm was honored to work with and thank for, and hopefully we'll work with many of them again.
My last question on my list, which we may have kind of already covered, but maybe you want to say a little bit more, is about the lasting impact of VMware's technology and these innovations.
Right. So we touched on that. So everything you have now in cloud computing, the foundation of it is a hypervisor, an x86 hypervisor specifically, because that's what made it economically viable. Right, so if you look at pretty much any cloud, most cloud services today, they all run on some hypervisor, like all of it. Whether that's Amazon or Google or what have you, and VMware made it possible, and because it was there was sort of a adversarial and cooperative relationship between VMware and Intel, and eventually Intel came in and built chips and AMD to make it more tractable, but VMware made it viable, and then AWS and Microsoft and Google kind of came in, and there were a couple of other startups. There was something called Kubernetes that became KVM, that is a Linux module that basically does similar things that VMware does inside the Linux kernel. And commercial clouds today, public clouds, all use that. AWS and Google, and are based on this technology. So all of it goes back to VMware. So this is a lasting impact. It will probably last for a very long time. Because it's a foundational piece and it's almost impossible to replace. So whether that will be VMware hypervisor, some other hypervisor, but basically, and amusingly enough, they sort of revive the technology IBM developed in the 60s and make it sort of the foundational piece of the modern world. So that's sort of an obvious outcome. There were many other things that VMware made possible. For example, during pandemic, people switched to remote work. VMware had a client product for remote work, right? So that was helpful. There is something called Horizon, and VMware not only had a product, it was the first product in this space, and of course Microsoft and others came in with similar competing products. But yeah, especially during the pandemic, lots of people were using it for remote work. Let's see.
It seems to me that also what we've learned about the way that VMware made things cost effective and efficient and attractive in terms of storage, and that does enable offsite work. That is, that if you can link to those things anywhere, if a company can make it economical for people to access their resources from wherever they are, then
Yep. And so here is one example. When the pandemic started, VMware shut down, and at one point we had a storage appliance, and they wanted to do an evaluation, and they wanted us to bring a sample, and we drove that appliance here to campus, but they wouldn't let us in. Because everything was shut down, and in particular, they wouldn't let anybody. So VMware has a couple of small data centers on campus. They just wouldn't let us in. So everything had to be done remote. And yeah, without having tools for remote connectivity, none of this would have been possible, or without virtualization technology. So that is a lasting impact for sure. Of course, the storage landscape changed completely. Even sort of, you don't think about it, but even these smaller quote-unquote industries like backup, well, most of backup is VM backups today. So there was a host of products and companies created over the past 25 years just catered to that industry. But without this, banks wouldn't exist. Here's another example. And that I knew even when I finished my first tenure at VMware. 90+% of ATM machines in Europe run VMware, so you wouldn't be able to use your ATM cards. As a reason being there's multiple applications and they wanted to separate them. Hospitals, from my Datrium days, most of them run VMware in hospitals. Walmart, all the stores run VMware. Defense industry, I'm not going to say even what equipment runs VMware, but there is a lot of it. So you can go on, and without, there's lots of specialized field that wouldn't be possible.
That's all I have on my list. Is there anything else you'd like to share about your time at VMware?
I'm just anxious enough to see the next chapter in VMware's life. I have seen several, and it was never boring, and I'm hoping it's going to survive and do just as well this time as it did in the past.
Thank you so much.
Thank you.